and throttle up. Discovery, go and throttle up. Discovery, go and throttle up. Discovery, go and throttle up.
All right. Let's see what this entails. So, what's going on, everybody? This is going to be an actual press conference, not just a phone interview thing like it was before. So we'll see what's going on. The sweet Italian American voice. Hey, we have the meatball connection. You have the Swedish meatballs with the Italian meatballs. I have the Italian American meatballs, which are like the Italian ones, except more fattening. You know, it's great. Yeah, there we go. There we go. Jim, I got your email back. Yeah. Dude, it's cool. It's cool, but I can't say anything about it, you know? Nice, dude. That's cool. All right. Sorry, I was talking to Jim about something. I might be able to tell you guys about that later. But, yeah, I don't want to say right now because it could be bad. Dude, bad hair. Bad hair today. All right. Anyway, so we have the Starliner OFT-2 press conference. This is the pre-flight press conference. Building a rocket finally? Nah, I wish. I wish I was that cool. No, it's something completely different. Yeah, no, it's Hellfish. I can't say. The reason why I can't say is because it'll geolocate me like worse than normal. Yeah. There's something going on locally it's a local event, but dude, I'll tell you guys about it later when it's done. Yeah, it's not anything space related, I'll be honest with you, but it's still cool. All right, so we're waiting for NASA's presser here, and you know what? I'm just gonna. It's Ford related? Nah, not really.
Discovery,
I know where you live. Yeah, I know. You remember? Can you believe that guy? Yeah, no, that guy got banned, but he just made another account. But whatever. Hey, progress is progress, man. It's very unrelated to the stream. Yeah, no, that's true. It is. Hey, Blue Tie, 17-month resub. Maybe it's a car show. Would I say that a car show is unrelated to the stream? Come on now. You mean Brimo's finally making an honest man of you? Good luck with that one. Good luck with that. Oh, boy. I'm gonna learn, yeah, interpretive basket weaving. Yeah. I'm going to, let's see. I'm going to be a French chef. We are going to the Cordon Bleu and weave baskets. Wonderful Tuesday to you. Dudes, I took 2 days off. Okay, so I think this was the first time in a long time that I've taken 2 days off in a row and had it not been vacation. I cannot tell you the last time I actually had just a weekend, so to speak. And you know what? It was weird. It felt like way too much time away from the stream. I don't know. I'm going to try it again next week. But, man, dude, halfway through Monday, I'm like, what do I do? This is too much time. What do I do? I don't know what to do. I have all this extra time. But are you well rested, though? Yep. What's up with all these testosterone pill commercials, man? Could be targeted ads, Senchai. Still have not heard anything yet, but it's not been a week. Yeah, 12. You know what? I haven't heard anything either, but we'll see. Well, you look extremely well rested. I mean, I got a lot of sleep. Yeah. Never realized how wasteful high-end French cooking is. I wouldn't know, dude. I don't know anything about that, you know. Can I build a TNT cannon for a special occasion salutes in Minecraft? Nah, no. Human don't. Somebody will just break it. I don't want to do that. Yeah. Yeah, Primo and I went to the beach yesterday. It was sweet. It was awesome. Primo worked remote, and we freaking working on a beach. So ridiculous. I can't believe that actually worked, Bree. My in-laws take my kids to the beach for the summer. After the first day or so, I'm honestly sitting around trying to figure out what I'm supposed to be doing. I'm like, I have all this free time. What do? Shh. What if they're watching? Oh, okay. Of course, Jeff had to drop some big space news on your day off. Yeah. Phil, is it bad if I read that news and I went, oh man, this is going to really piss people off. This is going to really piss people off. Yeah, people are going to be really mad. Could we build it from bedrock? Nah, human, I don't want to do that. If that's... Please understand. Oh, please understand. It's time. Here we go. Blue Origin has to bribe NASA? Yeah, I mean, SpaceX did the same thing, but no. When SpaceX does it, it's all privately funded. But when Blue Origin does it, and they're a little more overt about it, everybody hates Jeff Bezos. That's funny to me.
For scientific cooperation between countries.
1-0-0. Liftoff. Americans return to space as Discovery clears the tower.
Discovery, go and throttle up.
Discovery, roger. Go for deploy.
Beyond Bluefoot.
Everybody in the shuttle program, equipment go for launch.
Roger. Nice to be in orbit.
We have followed in their footsteps to get us where we are today.
Here we
Hey,
go.
from NASA's Kennedy Space Center, Florida, welcome everyone to today's traditional pre-launch news conference. It's good to be able to say that. Following today's launch readiness review, ahead of NASA, Boeing, and United Launch Alliance's
Audio good?
Orbital Flight Test 2 mission to the International Space Station. This will be the second uncrewed flight of a Starliner atop an Atlas V from Space Launch Complex 41 over on the Cape Canaveral Space Force Station. And this one is going, obviously, to the International Space Station. Here to provide details of today's review
Okay.
and readiness to proceed toward launch are a distinguished panel. Let me introduce them, and then I'll turn it over to them. Steve Stitch, manager of NASA Commercial Crew Program here at Kennedy Space Center. Joel Montalbano, the manager of the NASA's International Space Station program based at the Johnson Space Center in Houston.
All right, fellas, what I'm going to do here, they're introducing people, so I'm gonna make this quick. I shut up during press interviews. I do not talk. So I'm going to be muting the microphone, and this is the time where we listen, okay? Because they always drop little bits and pieces of information, but it's quick. It comes at you very fast. So this is the time to learn. So put your talking caps over there and put the listening caps on. This is the time to listen. So do what I do. Let's just chill and just listen for a second. Don't try to weigh in on anything till the end of the presser. Trust me on this. So I'm going to let Steve talk here.
This review this morning. When we look back to last week, we had our agency flight readiness review on Thursday. We've closed out all of the open work from that review. We had a good, thorough launch readiness review this morning, and we're in good shape to move forward and to roll the spacecraft out and also the launch vehicle. It was great to be up at Launch Complex 41 this morning. We got to walk down the launch vehicle and Starliner and see the Atlas, the Centaur, and also the Boeing Starliner spacecraft, and it looks beautiful. Really a testament to all the teams that have worked so hard from Boeing, NASA, and ULA over all these 18 months to get ready for the flight. Gary and John will talk a little bit more about processing the hardware, but we're on track for the launch on this Friday, which is launch time of 2:53 p.m. Eastern. We do have multiple backup dates. Right now, the range would not be available on the 31st, but we would go likely to Tuesday, August the 3rd, with a backup launch time of 1:20 p.m. on August the 3rd. We talk a lot about the launch and getting ready for launch, but it's a very important flight for the commercial crew program, having our second space transportation system available to carry crew to space. This flight will test many of the important systems on the vehicle in preparation for crew, such as the rendezvous sensor package to dock with the International Space Station, the NASA docking system. It'll be the first test of that system on the vehicle. And then when we get docked, there's a lot of activities we're going to do. We'll do some audio tests with the crew to test the comm system with the crew from space using the space station assets. We'll see how the vehicle performs on orbit in terms of the thermal performance, and also while docked, the atmosphere exchange. And we'll do some tests also with the crew tablets and syncing those and taking data off of Starliner through the space station and then updating the tablet. So it's an important test flight for us. Right now, the plan would be to undock as early as Monday, August the 5th, and land that same day. And we would look forward to that as well. We'll stay up as long as we need to relative to weather. The ISS has plenty of consumables, but we're excited about the flight and looking forward to a great mission. And now I'll turn it over to Joel Montalbano.
Well, thank you, Steve. Again, welcome to today's press brief. This week has been very busy on board ISS as we prepare for the MLM docking this week and then the OFT-2 launch and docking. We have been keeping the crew up to speed on all the operations that have been happening here on OFT-2 preparation, and they're excited as we are. With 7 people on board, we have an opportunity to maximize the use of the International Space Station, maximize the use for research and utilization, the technology development that we'll use to go back to the moon, and for low Earth orbit commercialization. So it's really been nice to having all 7 crew members. So with 3 NASA crew members, a European crew member, a Japanese crew member, and 2 cosmonauts, it's really been a pleasure to have this crew on board. As you heard, we had our launch readiness review today with the Boeing team, the ULA team, and the commercial crew program. And the ISS program is not working any non-standard open work. So we're ready to go for launch, and we're excited to have that. Steve talked about the launch time at 2:53 p.m. Eastern Time. We're carrying about 475 pounds of NASA cargo up and approximately returning 575 pounds of NASA cargo. And so we're excited to have another vehicle capability. Once this vehicle is docked, this will be the first time we'll have 2 U.S. crew-provided vehicles on board the International Space Station. So while we've had 2 crewed vehicles before, they were both Dragons, so this will be the first time we're having another provider on board. And that adds to the robustness of the space station program. And that helps us, not only the NASA agency, but it helps the partnership across the globe and allows us to bring people to and from the International Space Station and have redundancy in that process. And again, maximizing our use of the great space station we have. I tell people all the time we have awesome jobs, and in fact, I tell people we have the coolest jobs in the world to work in the space program and work with people across the globe and to make things happen. It's been a pleasure working with the Boeing team, the ULA team, the commercial crew program, and obviously our international partners and everyone involved in making this mission a success. So we're excited. We're looking forward to do that. And with that, I'll pass it over to Jennifer. Thank you.
Thank you, Joel. I'd like to talk for a few moments about the research we're doing on ISS, as well as some of the experiment hardware we're going to be bringing back on this flight. To date, we've done over 3,000 experiments on the International Space Station. Those come from over 100 countries and have resulted in over 2,000 publications, and we've served over 4,000 scientists and researchers. On this particular flight, we're going to be bringing back hardware that has been used on board to support some of those experiments. 2 of those experiments are in the field of tissue engineering. So we'll be returning hardware from the magnetic 3D cell culture experiment. That is from a company called In3D Biosciences. They developed and commercialized a cell levitation technology using magnets. And what this does is it supports the cell's binding to magnetic nanoparticles, which then can be magnetized into 3D aggregates. This is really important research that we've been doing in microgravity. We know that cells more readily form 3D structures and spheroids in microgravity, and so this was one of our early research and development as well as tech demos for bioprinting. We're also going to be bringing back hardware from antibody drug conjugates, or ADCs, in microgravity. This is in the field of cancer biology. This experiment tests antibody and drug conjugates using cancer therapeutics attached to antibodies. So what this does is it allows you to target specific proteins on the cells, on the outside of tumor cells. This not only can create more effective therapies, but also can reduce side effects since the drug delivery is very specific. We just talked about how the cells more readily form 3D structures. It is also believed that potentially doing this type of research in microgravity could approximate the 3D structures of tumors more in the human body than what you would get from trying to grow these in 1G. We're also going to be bringing back experiment hardware in the field of complex fluids. That is PACE, our preliminary advanced colloids experiment. This was an initial experiment used to calibrate our light microscope on board and enable an entire suite of advanced colloids experiments that continue today. And now I'd like to hand over to John.
She's
Thank you, Jennifer.
She's the one here doing all the science.
Well, it's a pleasure to be here today. I would like to show a slide from this morning. Steve mentioned that we walked down the Launch Complex 41 with the vehicle. You can see the Starliner there atop the Atlas V vehicle. In the background, you can see the Launch Complex itself, and so we are looking forward to getting there. So we made it one of our objectives for this mission was to be full kit. We wanted to avoid any traveled work, and so I'm very proud of the Boeing team, all of our supplier partners with ULA, Aerojet Rocketdyne, Collins, ILC, and many others. But they, along with us working side by side with NASA, have, through this entire journey, we made it through FTRR, the FRR, and then this morning, the flight readiness review with very, very few actions. And so we're very pleased to have been able to accomplish that with a very clean vehicle. And that was one of our objectives. We tried to make the Starliner for this trip, this mission, as close to a crewed vehicle as we could. And so we will be obviously working all the objectives and the flight demonstrations to prove that out. We will do everything we can except for the man in the loop. And even in those cases, we've enabled the abort. So that will be enabled for this flight so that we can check that system out. So another one of our objectives, we have our ops teams in both Houston with mission operations. We have our ULA team here at KSC, and we also have our Boeing Mission Control Center here at KSC. All the operators have been certified and trained, and they are ready to go for this flight. So we are very excited to have the opportunity to complete this test flight and have it be a leader for our path for the crewed flight to get us to ISS in the future. And with that, I'll turn it over to you, Gary.
Thanks, John. ULA is excited to be here to launch the second orbital flight test in partnership with NASA and the Boeing company. This will put us one step closer to flying astronauts to the International Space Station from U.S. soil. We're especially honored to partner with Boeing and NASA and really appreciate the trust and confidence that they've put in our team in the Atlas V to launch the Starliner to space. This second flight gives us an opportunity to further analyze the mission-unique technologies that were developed specifically for use on the Atlas V and the Starliner configuration. These include a dual-engine Centaur like we launched on OFT-1. That has history back into Atlas II and Atlas III, and we plan to use that on future Vulcan Centaur flights as well. This Centaur uses an Aerojet Rocketdyne RL-10 engine that was specifically designed by NASA back in the 1950s and 60s. And for this mission, we actually fly 2 of the RL-10 4A2s on the Centaur upper stage. The second technology specifically for this configuration involves the aeroskirt that was designed and put in place to improve the aerodynamic surface and to protect the Centaur upper stage from the loads, the aerodynamic loads that impinge on the vehicle during flight. It's a metallic orthogrid structure that you'll see when we roll out to the pad. You'll be able to see that structure extending down below the capsule over the upper stage. Unlike the orbital flight test, a couple things have been mentioned about the aborts. We flew the orbital flight test in a passive mode, doing data collection on all the telemetry and vehicle parameters. On this flight, we actually are activating that system, and so in the case of any off-nominal data that we get from the vehicle, we can actually command an abort to the Starliner. I think we have a photo that I can share of the vehicle. It's actually in the VIF, and we're on track from a health and status perspective. We walked down the vehicle today. There are no issues. They're doing some final closeouts. We're not working any issues, and all the planned work is nominal going forward with a scheduled roll to the pad tomorrow morning. We completed the LRR and look forward to a launch on Friday. And with that, I'll pass it off to Will Ulrich for the weather.
Thanks, Gary. Kind of feels like all eyes are on weather at this point. So anytime me and my colleagues see a launch being put on the schedule or on the calendar during the summer months from Kennedy Space Center or Cape Canaveral Space Force Station, we always have to be prepared for a challenge. And this particular launch is no different, especially given the time of the instantaneous launch window just before 3 p.m. You know, this time of year, anyone who's familiar with East Central Florida weather knows that each afternoon we typically see showers and thunderstorms over the area. But it really is dependent upon the placement of the Bermuda High out over the Atlantic waters as to whether the west coast of Florida or the east coast of Florida is favored for shower and thunderstorm activity each afternoon. Well, this week, the Bermuda High is to our south, which leads to offshore flow or west to east winds. What that means for you and I is it typically favors showers and thunderstorms on our side of the coast, which is obviously not good news when you're attempting to launch at 3 o'clock in the afternoon. So that's part of the reason why, if you've seen our forecast from the 45th Weather Squadron, we're a little bit pessimistic going into week's end, but we do have to be realistic with that. So if we take a look at the forecast, you'll see our probability of violation at this time is 60%. That's a 40% go, with 3 primary concerns. At the 45th Weather Squadron, we evaluate 9 separate lightning launch commit criteria. I highlighted 3 on the slide here, including the surface electric fields rule, the cumulus cloud rule, and the lightning rule, all rules that are designed to protect from both natural and rocket-triggered lightning. In addition, we'll be monitoring winds and other user constraints, but overall, outside of any thunderstorms, we are expecting favorable winds and temperatures in the middle 80s, not atypical for this time of year, and southerly winds up to about 15 miles per hour. So with that said, we have to be realistic going into late week, and we can hope that we'll find a gap in the shower and thunderstorm activity that we're anticipating. But regardless, the 45th Weather Squadron is ready to support, regardless of what Mother Nature throws at us. Thanks.
Okay, thanks, Will. Thanks, everybody else. And we're ready to take questions here in the room, which, by the way, it's good to be able to say that again. And on the phone, we have some folks on the phone lines as well, so we'll bounce back and forth. And let's start first with Irene right here in the middle. And if you would, Irene, give your name and affiliation for everybody listening, and if you have a person up here to direct it to, do that also. Thanks.
Thanks, Kyle. Irene Klotz with Aviation Week. Either for Gary, probably for Gary, does the fact that you have a fully armed launch abort system affect the weather launch criteria at all? Are you looking at abort zones like you would if there was a crew on board, and would that impact your ability to launch on Friday?
So from a United Launch Alliance perspective, we're looking at all of that. It doesn't, we don't differentiate whether or not it's active or inactive. We have set launch constraints, and we'll adhere to those regardless of whether or not the abort system is activated or not. From a mission operations perspective, I think Steve's probably better.
I'll add a little bit to that. So we'll have the abort system active. So if anything were to happen, it would separate Starliner and land the vehicle. We're going to practice the abort weather for this flight, but we won't make those mandatory constraints. In other words, we'll just use the launch weather for this flight as the primary weather criteria, and we wouldn't hold the launch for abort criteria, but we are going to look at them and go through it just like if our crew were on board when those launch abort criteria would be in place, and we would follow those for the flight.
Okay, let's head to the phone line. Bill Harwood, CBS News.
Hey guys. A quick question for maybe it's Gary or maybe it's Mr. Vollmer. Can you give us a little bit more detail on the EDS system, the emergency, the fault detection system you've got for this flight that'll be live? I'm not clear on how that ties into the Atlas's, the self-destruct system that's always been in place on Atlas. How does that work? So if it triggers an abort, the capsule gets away, right? But what happens to the rocket and all of that? If you could just provide some background, I'd appreciate it. Thanks.
Thanks, Bill. I'll take a first cut at that. Okay. The quick answer is it's measuring. It's got 25 different measurements. It's looking at tank pressures. It's looking at our avionics, our flight control and attitude, and the propulsion systems, and it's verifying that they're performing nominally. And then if it's starting to see a trend where there's starting to get some issues with the vehicle, it'll actually initiate a command to the Starliner for an intent to an abort. So it's up front of the FTS, and if it's rapidly occurring, then it would kick it off sooner. Otherwise, it would just inform Starliner of what was going on the vehicle.
Right. From a Starliner standpoint, we actually have multiple abort modes depending on which phase of flight we're in. So fortunately, on the OFT-1 flight, we were able to evaluate the abort system on the ULA Atlas V. So with that data, we are very confident in activating that system and getting that prepared for our CFT flight. Once again, trying to make this vehicle as close to the CFT vehicle as we can. It allows us to go through and also demonstrate and validate that system. So,
Ken?
Hi, Ken Kramer, Space Up Close. For John Vollmer, I have a question. You mentioned this Starliner is as close as you could make it to launching humans. I'm wondering if you could actually launch humans on this flight, and if not, what would you have had to add? And if you could just tell us a little status of the other two Starliners. Thanks.
Okay, so we probably could have launched crew on this flight. We did not load some of the oxygen on this flight on purpose. We loaded nitrox instead of oxygen, so that would be one change we would have to do. But we have the full complement of hardware. The suit fan is in there for the suits to connect to. We're going to have a simulated suit connected so that we can validate that system. What was the second part of your question?
The other Starliners.
Oh, the other Starliner. So this is actually the Starliner that went through our environmental qualification testing, and then it's been refurbished for this mission. The OFT-1 Starliner vehicle is being refurbished for the CFT mission. Those are the two primary vehicles. Our third vehicle was our test vehicle, and that remains, it will not fly again. It remains a test vehicle, and we use it for human factors analysis. We use it for fit checks for equipment and things like that. But those are our two primary vehicles that we will continue to turn around. They're certified for 10 flights each.
Okay, back to the phones. Gina Sansari, ABC News. Okay, let's take another one in the room right here.
Hi, Rachel Nail with Florida Today. For Steve, I'm curious, whatever happened with the Boeing organizational safety assessment? When was that finished, and what were the results?
Yeah, we did complete an organizational safety assessment over the summer months in the June timeframe at the Kennedy site here and also in Houston. And I think we've got some good information to go look at, and that data really goes back to the Boeing and NASA team to utilize for to go ahead and prove things. And so, I really can't share too much data. It really goes to Mr. Vollmer and the team as well to take that data. But we didn't really see anything in the survey that was surprising, I would say. Boeing has an excellent safety culture that we've seen. We knew that before we did this OSA in working side by side with Boeing. But we'll take some feedback from employees, and then we'll take that and make the program better, both on the NASA side and also on the Boeing side.
Yeah, okay, right there. And I'll add to that we were very pleased to work with NASA. We worked cooperatively on the organizational safety assessment. We assessed both our workforce in Houston as well as the workforce here at Kennedy Space Center. The results we just outbriefed just recently, and so we are ruminating over those, and we'll assess what the opportunities are that come out of that. We were pleased with how the review went, particularly the professionalism that NASA showed and how they conducted the review, our allowance to be involved in how that review was conducted, and there's always room for improvement. So we're going to be looking for where are those areas where we can make improvement.
So will it be released or no, it won't be released?
The plan would not be to release the data. Again, when we do these, you really want employees to feel free to speak exactly the way they feel, right? And so for them to provide that data in a very forthright manner, you have to protect that data. And so we won't really release the details of what came out of that organizational safety survey. We've done a number of these at NASA across many different providers and also within NASA as well. And the process really is to let people say what they think. And so if you release that data, you don't really get true data from the employees. And so, John and I did get an outbrief. I can say, just a core value of Boeing and a core value of NASA is safety, and that comes out very clear in the survey that safety is the #1 priority. And then the team also, we do see that the team is dedicated to the mission and dedicated to this OFT test flight and dedicated to flying crews safely as well. So that's probably about all I could comment on.
Okay, go ahead.
Hi, I'm Amy with Space.com, and my question is for Mr. Vollmer. I wanted to talk about Rosie, the dummy that's on board. I know that you said this launch you probably could have put crew on board. So is there anything new with Rosie as far as sensor-wise or different things like that with this flight?
We took a little bit different approach with Rosie this time. Last flight, she was fully censored, and we used those sensors, and they were very valuable data that we got back. This flight, Rosie's there, but she is essentially ballast. And we are taking measurements. We've put censored in the seats and other locations in the vehicle as we found that we thought that would be more valuable since we'd gotten the data from Rosie on the first flight. So a little bit different approach, but she's still there.
Okay, let's try the phone line. Do we have Gina back from ABC News?
Yes. How many full mission simulations did you run in prep for this?
I'll take that one. I don't know the exact number of total mission simulations that we ran, but I can tell you it was in the hundreds and hundreds of mission simulations. We ran mission simulations as we went through the development process. We ran mission simulations as we went through the test process. And then when we were completed with all the tests, we ran an end-to-end simulation, including all of the operations centers at KSC and Houston, and we even involved the crew in some of that so that they actually sat on a simulated flight deck. So I don't know the exact numbers, but I can assure you it was in the hundreds and hundreds of simulations that we ran, and literally thousands of hours.
Okay, let's take one more from the phone. Jeff Faust with Space News.
Hi, Jeff Faust, Space News. A quick question on schedules. If you aren't able to launch on Friday and aren't able to launch on August 3rd, when is the next available launch opportunity? And what is the range issue that appears to prevent a launch opportunity on Saturday? Thanks.
So our next launch opportunity, if we don't go on the backup day of the 3rd, is the 4th of August, and it moves back on the order of 20 minutes in the lunchtime. And the operation on the range is a classified operation that they're conducting. And so we're continuing to be ready in case that operation doesn't go through, and we could launch earlier, but unless it moves, we'll just stick with the launch on Friday and follow up on the 3rd and 4th as backup days.
Can take another question in the room. Anyone else? Irene, go ahead.
Always have more questions. For Joel, following up from the post-FRR press conference on the opportunity to fly cosmonauts on the commercial crew vehicles and vice versa, Kathy previously had said that was going to be targeted between Crew 2 and 3. It sounds like it might be later now. Do you have another estimate of when that might be?
Yeah, it will not be on Crew 3. We're looking at try and get everything ready to go for the Crew 4 mission is our goal. But again, we'll have to continue work with our State Department, the Russian Ministry of Foreign Affairs, obviously NASA and Roscosmos, and then go through the standard process. We have you probably are very familiar with the multilateral crew operations panel process that we have, and we'll have to work through that. But it will not be Crew 3, Crew 4 at the earliest.
Okay, hang on. We'll go to the phone and then back here, Ken. Let's see. Eric Berger, Ars Technica.
Hi, thanks for doing this, and best of luck with the mission and launch this weekend. First question is for Steve or Joel. Can you say how much how much NASA is going to pay Boeing for the cargo delivery, the hundreds of pounds up and hundreds of pounds down that you mentioned? And then a question for John. Generally, can you provide any details on the number of software code changes that were made between OFT-1 and OFT-2? I know you did this analysis and obviously ran all kinds of simulations, but at the end of the day, were there lots of code that needed to be changed, or was it relatively minor? Thank you.
Yeah, I'll take the first question in terms of what we have paid for the cargo delivery to the space station and return. I mean, this flight, Boeing decided on their own to fly a second orbital flight test before they go embark upon the crewed mission, and so NASA did not pay for the cargo delivery at all for this flight.
Okay, and on your question on flight software updates, so coming out of the OFT-1 mission, there were some recommendations out of the independent review team. We incorporated all those recommendations. That was relatively small set. So we incorporated the timer change for the MET Epic. There was a service module disposal software change that we implemented. Actually, the biggest change in software was in the communications code. We found that the communications was not as robust as we would have desired on our first flight. So we spent some effort modifying that code, mostly antenna pointing algorithms, some fault detection and recovery algorithms that we changed. We also added an algorithm so that if we lost comm, that the system would automatically reset and go search for comm. And then we added an algorithm that made sure that post-separation that we had an antenna that was pointed back at Earth so that we could get communication from that antenna. So those were the big ones. There were numerous other changes made to flight software. The majority of those were additions to the flight software for additional functionality that was added to the vehicle, consistent with going from the the OFT and bringing us up to the crewed version. And so those changes, and then, of course, learning. We incorporated learning from the first flight into the software.
Okay, Ken, you got a follow-up?
Thanks, Ken Kramer, Space Up Close again. And again, good luck. If I didn't say it the first time, good luck. For Joel, I have a question. This could be for Jennifer, too. When Nauka docks, hopefully it will dock safely, and the Russians, I think, are going to, correct me if I'm wrong, maybe upgrade to 3 crew members. So I'm wondering, would the ISS at some point soon after that reach 8 crew members, and how would that affect the crew and the science on the U.S. segment? I think you have 5 now, but would it go down to 4 if they don't, or how would Nauka impact all that?
Sure. Now, our long-term steady state is 4 USOS crew members, and so 4. And so when the Russians, when they get to the point where they step up with 3 cosmonauts, we'll stay at the 4 USOS. And then what was your second question?
Well, that was it. So
Okay.
they're not going to go to 8 then?
No. We'll stay 4 on the USOS and 3 on the Soyuz.
So you definitely have less U.S. science or partner science then, I guess.
I'll start and then Jennifer can add. The cool thing about the International Space Station is we work, across the partnership, right? So today we have cosmonauts participating in U.S. experiments and then vice versa. And so we'll always be working together. Now each agency has their national goals and we work those in, but we'll always continue working across borders.
Let's go back to the phone and Joey Roulette with The Verge.
Hey, thanks. My question was asked.
Okay, great. Yeah, go ahead. We'll come over here in a
Hi,
second.
this is for John. Last year, I understand that Boeing hired, I think for the first time, some sort of executive level software person who looked at, software among all aspects of Boeing. Could you tell us a little bit more about that role? When was that person hired? And how did you at Starliner interface with that person? Did they have specific recommendations for the Starliner program? Like what specifically came out of that?
Sure, I'd be happy to. So actually, even before that, we looked at software, and we have capabilities within the Boeing organization, and so we implemented a software capability as a dedicated engineering discipline to make sure that we were looking at software holistically and that we were implementing it holistically. The other thing we did was we embraced making sure we were looking at hardware-software integration and not just software as a discipline alone. So that's made a big difference on our flight this year. We've put a lot of effort into making sure that we are integrating hardware and software throughout all of the life cycle of the software development. So that's a big change from where we were. As far as, and Jenna was our the individual we brought on to the executive ranks. So Jenna has participated. He participates in all of my monthly reviews. He's provided input on recommendations for software updates. Specifically, he's been looking at the CFT software and looking at other ways to test the software and make sure that we've addressed all of the logic paths in it. We went through a great deal of effort to ensure that we had addressed all complex and non-complex logic paths, and Jenna has brought us some new tools to help us do that more efficiently. So we welcome his input, and we are incorporating that into our development process.
I'm going to go to the phone, and then you're next. Camden Hall, talk of Titusville.
Yeah, hi. Thanks for taking my question. My question is for Will Ulrich. If, say, we had a scrub on Friday, could you give us a rough forecast for August 3rd, your next launch opportunity? Thanks.
Yeah, you're talking about a launch Tuesday, so we're, an entire week away. So it's a little early for me to even discuss what the actual forecast would be, but we can look at it from a climatological perspective, and that tells us that Given the time of the launch, which I believe, correct me if I'm wrong, it's would be closer to around 1 or 1:30, a little bit earlier in the afternoon, which would be a good thing because at that point the East Coast sea breeze hasn't yet fully matured and we haven't seen as many showers and thunderstorms at 1 p.m. as we will at 3 p.m. So overall, from a purely climatological perspective, I would say that the probabilities are lower. But when it actually comes to the forecast, that first probability of violation forecast that we put out, that won't come until Friday morning. So I really can't talk to it just yet.
Okay, back here, go ahead.
So really, whoever wants to weigh in on this, but this pre-launch news conference kind of signals the beginning of this countdown, right? Everything has been leading to this moment on Friday. You've talked about a lot of the technicalities about the software. I want to know, how are you feeling? How are you weathering the excitement or the nervousness as you look at other companies around you in the past few weeks, or even given the last flight? I want to know how you're feeling today.
I guess I can start. I mean, been in this business a long time. I was just thinking back to a July launch on Space Shuttle. July 4th, in the middle of the afternoon, we launched 121, the second return to flight mission, and it was that was an exciting flight. But we talk about weather in the afternoon, and sometimes you can launch in the afternoon. But I would say for any flight, I'm excited, I'm anxious, and looking forward to it. But I think if you're not a little worried or concerned or have a little bit of that tension in your stomach, like what we're about to do is really challenging. We want it to go well. We expect it to go well. We've done all the preparations we can possibly do, and the Boeing team and the NASA team continues to do that, even running simulations up until the last minute. But, there's always a little bit of that trepidation in you that, hey, this is spaceflight. The Atlas is a great vehicle. Starliner is a great vehicle, but we know how hard it is, and it's a test flight as well. And I fully expect we'll learn something on this test flight. We have a lot of instrumentation on the vehicle, strain gauges and pressure temperature measurements and accelerometers and all kinds of things. And so when we get back, we'll take that data and then fold it into the crewed flight test as well.
Anybody else in the room?
Yeah, I'll add in that,
Sorry, John.
Of course, we've been 18 months preparing for this, right? And so I am confident in our vehicle. That said, we do have to, ensure that we are carefully watching all the systems. We want to learn from this flight. We want to let the hardware talk to us so that we understand, what it's telling us, right? Because there's a lesson to be learned there. On the first orbital flight test, we learned a lot. We learned that we had a very robust vehicle, in fact. It performed better in a lot of respects than we, had expected. So we tested that vehicle. We learned those things. We learned that our communication system was robust, so that we made the changes there. We made the changes in our software. We have spent the 18 months really trying to wring this vehicle out to have a lot of confidence that this flight will be successful. We will learn something out of this flight. There's no doubt. But we want it to be a successful flight, and that the learning is something that we incorporate back to make this a safer, more robust vehicle.
Okay, let's see. I'm going to jump in with a question, reformulated a little bit for online. But how long will Starliner stay at the ISS, and what will be the main mission objectives? I think the question is alluding to what did we get done on the first test flight that we may redo on this flight, and also accomplish all the other mission objectives that we had. And that may be for you, Steve, and also for John.
Yeah, I can take a crack at it, Kyle, and then we'll let John add to it. The first flight, as John said, I think we learned that we fundamentally had a very solid design in the spacecraft in terms of the crew module and the service module. That mission, in some ways, performed better than we would ever anticipated with the number of thruster firings we had, the way that the battery and power system performed, the way the GNC system performed, the prop system performed well, the landing and guidance, we landed almost a bullseye at White Sands. So that part of the flight went extremely well. The part that we'll really focus on here is going into the approach ellipsoid and testing the rendezvous Vesta sensor system. That's necessary to get in close to ISS and track the docking interface, docking with the International Space Station, testing out the NASA docking system. That system's provided by NASA. Starliner's computers control that system, getting into docking, and then once we dock, opening the hatches, and then power transfers back and forth between the vehicles. So while the vehicle's at ISS, we'll flow power over and provide power to the Starliner batteries. We'll exchange data and caution and warning between the vehicles while we're docked. We exchange atmosphere back and forth. We'll look at the temperatures in the cabin and learn a lot about the flow rates. And then there's an emergency communication system between the vehicles. So if a crew were in Starliner in some kind of a safe haven or emergency, they could talk to the crew on the ISS side. So it's really all those kind of things that we'll learn. The plan is for the flight to be relatively short and undock as early as August the 5th. Should we launch on the 30th? We'll stay up a little longer if weather allows for it. And then, it really is just to learn about the docked part of the flight. That's the part of this flight that to me is so critical, docking with station, and then also on the back end as well, going through that whole undock sequence, testing the NASA docking system as well, and having Starliner back away, and then from there separating away and getting into the deorbit burn and landing. And I'll see if John has anything to add.
Yeah, Steve captured all of the major demonstrations of capability that we're looking to do. I think I would add to that there are systems that we test as best we can on the ground, but there are conditions that are only found on orbit that we're going to be able to fully test out some of our systems. So our Vesta system, which is our vision system for docking, we'll be very interested in gathering data from that system so that we can understand the characteristics of that system and how it operates in an on-orbit environment. So those are the additional things we'll be looking for is, once again, what's the hardware telling us and what do we learn from that?
Okay, thanks. We'll wrap up with just a few programming notes. Thursday is obviously going to be a busy day at the space station getting ready for Starliner's arrival, and also here on the ground. So be sure to join the NASA administrator here on NASA TV and in this room at 10:30 Thursday morning for an entertaining media and social event. He'll be also joined by some of the other agency leadership and some other special guests, so hopefully you guys can join us for that. Obviously, all of that leads to Friday. 2 o'clock is our start time for the broadcast. It's a comprehensive set of launch coverage that includes taking you inside some of the facilities here, Boeing's Mission Control Center, the United Launch Alliance's Atlas Space Flight Operations Center, and obviously Mission Control Houston. Liftoff remains scheduled for 2:53 p.m. Eastern Time. Thanks for joining us today, and be sure to follow us online at our main sites, nasa.gov/live for the live broadcast and live events, and also for the commercial crew program, nasa.gov/commercial crew. Thanks to the panel, and also thanks to you guys for being here, and please keep practicing social distancing. Thank you very much.
What do you think, dudes? So, okay, let me give everybody a little bit of a background here. So, hang on, I just got to reconfigure some of these windows. Okay. Bree, those are very nice. All right. Creeper, how you doing? Okay, that's over. Hi. Did they hire a sound guy? I balanced the audio from that press conference, guys. It was a little underdriven that time. I boosted it and then equalized it out. Yeah. But anyway. So let me give you a little bit of a background here. So the reason why everybody's up, if you're newer to spaceflight and you're wondering what's going on, This is the OFT-2 flight. The OFT-2 flight was never originally planned to happen. The reason is because the OFT-1 flight was supposed to basically quantify all of Boeing's testing data, and it was a full, more or less all-up test of the capsule. That launched in December of 2019. It turns out there was a timing, an epic time, what did he call it? He called it main time epic, I think. Miscommunication between the capsule and the rocket. Long story short, the capsule launch time was synchronized to the time where they turned Atlas V on. What does that mean in plain English? Basically, the capsule thought it was in space before it was in space. So when Atlas V deployed it, it started acting very erratically. It started just kind of spinning around. Because the capsule got really confused. The capsule's like, okay, I'm supposed to be here, but I'm not. Wait a minute, this isn't right. So the capsule started trying to go where it thought it would be at that point in the mission. Here's the cool part about this. Flight controllers at NASA figured out this problem, diagnosed it, and fixed it in pretty much less than 5 minutes. Yeah, the OFT 1 mission was not it was an off nominal result, but they fixed the problem and ended up getting the capsule into a nice stable orbit to prepare it for deorbit and landing. Now, unfortunately, because the capsule tried to maneuver where it was supposed to go, right where it thought it needed to go, they ended up using too much fuel. They basically did the equivalent of having SAS and RCS on at the same time and just, you know. So they ended up using the remaining fuel that it had left over to get it back. They put it into an orbit to get it back within a couple of days, and it did come down and it did land, and they secured that capsule, and that capsule will come back. It's the Calypso Starliner capsule. It will fly people into space. It's actually the one that's scheduled to fly next after this capsule. Now, that prompted a lot of... Basically, the really, really simple way of saying it is NASA said, what the hell, guys? What happened? You know? And Boeing was like, yeah, we should fix that, huh? And NASA's like, yeah, you should fix that. So what they did was they had a triple redundant accident investigation. Boeing had their own internal review team. NASA had an internal review team, and then there was an independent internal review team. And they all did an accident investigation. They did a triple redundant safety evaluation of Starliner, and they basically did trifold safety checks on this thing. And they figured out all the timing issues. There were some other timing issues with the heat shield, and there was some. John Vollmer was talking about tracking loops that needed to be opened and closed. What does that mean? Well, if you go back to the OFT-1 flight, the reason. So, okay, this is a testament to NASA's flight controllers. Now, Boeing does have an independent flight control team for Starliner. But Johnson Space Center in Houston, Boeing opted for the Commercial Crew Program to have Mission Control Houston working on these flights. So these flights are kind of a hybrid between a NASA-operated mission and a commercial-operated mission, which is really cool. I didn't know that. How I found this out was I asked a flight controller a long time ago. So I did learn some things. I asked a flight controller named... Allison Bollinger. She's an ISS flight controller. And I asked her about this stuff when we were at Intrepid in 2020, a little ways after the Starliner flight. Now, I didn't get this on the record or anything, all right? But she did tell me some pretty cool stuff. So, OFT-1 did not go very well, okay? The capsule was going to crash. The type of orbital insertion that Atlas V with the dual-engine Centaur is supposed to do is a little bit different from a regular Atlas V ascent profile. Now, why is that? Well, long story short, there's people on board. You need to make sure that you don't liquefy the people on board. So it flies it actually flies a very similar flight profile to the space shuttle. Yeah, it's a very similar profile to the space shuttle, meaning that at main engine cutoff, right? So when the dual engine Centaur flames out, and separates the capsule, that Centaur is on a very, very similar trajectory to the external tank. The external tank did not ever get into space during the shuttle program. Not into orbit, I should say. It went way into space because of the shuttle. But they often jettisoned it and it burned up over the Indian Ocean. Or, depending on the inclination and trajectory, over the South Pacific. The dual-engine Centaur was scheduled to burn up over the Indian Ocean. And the Starliner capsule was basically shooting out RCS in all different directions and basically tumbling end over end. This meant that, well, that Centaur is not supposed to survive one orbit. And the Indian Ocean comes up real quick when you're in space, right? Meaning that the flight controllers only really had 5 to 10 minutes at best to figure out what was wrong, fix it, and put the thing on a stable trajectory with enough fuel left over for re-entry. They did it in 5. They did it in 5 minutes. They fixed the capsule, put it in a stable orbit, and went. And they, you know what's even crazier? The flight controllers for this mission would have, saved Starliner and fixed the OFT-1 mission and got it to the ISS had it not been for a TDRS handover. That's why John Vollmer was talking about different communication systems on board Starliner. He said, we upgraded the internal clock, we upgraded the heat shield clock and the service module jettison, and we also upgraded the tracking. What happens is, when you're using the tracking data and relay system, all right, for NASA, there are satellites in geostationary orbit that are designed to keep in constant communication. If you have mission control in Houston and the capsule goes over the hill, right, it goes around the Earth, there's an Earth in the way, so you can't communicate to it. So NASA ends up shooting that signal straight up to a tracking satellite, and it bounces the signal to the Starliner capsule so NASA can basically see around the corner, right? They can see over the curvature, they can communicate over the curvature of the Earth. Long story short, while the flight controllers were trying to send commands to the Starliner capsule to correct it, there was a TDRS handover. The Starliner was over the hill, so it's like, okay, I don't have that one. Now, where's the other one? And it took it 5 to 10 seconds to acquire a new signal. And in that 5 to 10 seconds, it used too much fuel. The flight controllers would have saved it. And had there have been crew on board, they would have saved it as well. And they would have been able to get it to the ISS. But because of that TDRS handover, they couldn't. So that's why John was talking about communications and tracking and making sure that they have redundant communication and antenna capability to avoid something like that happening again, just to be 100% sure. And this is a testament to those flight controllers, to the flight controllers and the flight control team that were on console during OFT-1. And now, who was on console on OFT-1? Check this out. It's a guy by the name of Richard Jones. He's a flight controller for NASA. So, long story short, he was a shuttle flight controller for NASA. Richard Jones was on console. He was the flight director for STS-135. Yeah, pretty kind of an unsung hero. An unsung hero. Jonesy, does he make noises? No, but he saves capsules. Did Boeing pay the cost for OFT-2 in full? $400 million. Yeah, they paid it out of pocket. And they said that right after OFT-1. They're like, yeah, we'll pay for another test flight. Richard Jones used to work at OCP. No, no, the guy that was on console for STS-135 during the launch was on console for Starliner's launch, which is really freaking cool. It chose probably the most experienced flight controller that they have. A lot of people don't know that. And that's why I asked Allison about this a long time ago. Yeah, those guys fixed the capsule, figured out what was wrong, and troubleshooted it in less than 5 minutes. And the only reason they couldn't get it to the space station was because of the TDRS handover. Which is crazy to think about, fellas, because, let's see, if it goes more than 5 minutes, you have 5 to 10 minutes, the capsule's in the Indian Ocean. Yeah. It's pretty awesome, dude. Testament to the flight controllers. I really wish more people would talk about that. That tells me that it was a dumb mistake. I only fix dumb mistakes that quick. He's the guy with the shirt in the back. Yep. Yep. And that's why when I realized what was going on during the OFT-2 mission, everybody was whining about how, you know, like, oh, this cast is terrible. This cast is terrible. I'm like, yeah, the cast is terrible because something went wrong. Here's them troubleshooting what was going on. That's Richard right there. I'm pretty sure. What happened with 135? No, nothing happened with 135, Corey. That was the last shuttle mission. This guy's a shuttle flight director. So he's what that means in plain English is that he's used to flight controlling a much more complicated vehicle. It's pretty friggin' cool, dude. Dish, go Atlas, go Centaur, go Starliner. That's right, man. It's pretty freaking cool. So that's pretty cool to see, you know. I mean, dude, like that should be talked about in general about how good NASA's flight controllers are. It's literally like a Gene Kranz moment unfolding in front of our eyes, and everybody, I remember this very distinctly. I got pissed. I got really upset during this launch, not because they weren't showing pictures, but because we figured out what the heck was going on, right? And everybody was whining about not having camera angles. I'm like, they're not showing you camera angles because the capsule is careening out of control. They don't give a crap about camera angles right now, you know? Like, look at these guys. These guys freaking work the problem, people. We watched an Apollo 13 event unfold in real time in front of us, and we're worried about the damn camera angles, dude. Look at these guys. Steely-eyed missile men and women right there. That's freaking awesome. And look at Kathy's in the background like, okay, fix the problem. That's cool, dude. When is Starliner launching? The 30th. 30th at 2:56 p.m. Eastern, Tessa, so it's going to be about 8, 9 o'clock for you. See last, what I said. See last, what I said. He gets the title of Steely-Eyed Missile Man. That's right. Yeah, Scott's the one that pointed it out, and then I started noticing things. Forge, yeah. I noticed they weren't giving us any camera angles, but I couldn't figure it out why, and then Scott posted that. Yeah, exactly. The capsule's pointed down. Something went very wrong there. And then it hit me like, I'm like, we're watching them troubleshoot it. That's so freaking cool. It's so cool to me. It's something that people don't really remember from that OFT-1 mission. Steely-eyed missile men and women right there, fixing the capsule in real time. That's cool, man. If you work in IT, can you imagine? This is remote IT work to the maximum, you know? It was cool, man. They won't mess it up, Dr. J. No. Yeah, making a change in production. Yeah, Remo, only making a change in production, if you don't get it done in time, the software deletes itself. It has like a dead man switch. Can you imagine? If you don't make the changes, if you don't push the changes fast enough, the server deletes itself? That's not how that works, I know, but... As long as latency isn't too annoying, it feels like it's in the next room. Ando, they had latency problems because of the Tidris handover. That's what made that so cool. I can't believe they got that Starliner capsule back. It's pretty awesome, man. If you don't fix it fast enough, the server will crash into the ocean. If this fails this time, I'm quitting my job. Dish, it's not going to. It ain't gonna fail. I have faith, dude. Just like I had faith in the Russians with Nauka. Everybody said, oh, there's problems with Nauka. I'm like, no, there's not problems with Nauka. They haven't launched an FGB in 22 years. So, no, that's not what's going on. They're remembering how to launch a space station module. It's going to take some time. Gene Kranz, failure is not an option, talks about known knowns and known and unknown knowns. Like, Brimo, you're the one that reminded me of that a long time ago. That's true. You have things that you're going to... Dude, you can only prepare it so much. What are you preparing? You're always preparing. Just go. Just go. Sir, Ed, you better buckle up. No, it's seriously that. You can only prepare so much. Eventually, you're going to have to send it. Yeah, there's known unknowns and unknown unknowns. Like, you're not going to know how the thing performs. You can't do it. There's only so much comprehensive testing you can do on the ground before you have to launch something. And look, Nauka took a second, but they undocked Piers, man. They did undock Piers. That's the next bit of space news that I wanted to kind of talk about. They undocked Piers, and look, I know, dude, I'm not the best at this, but I know how spaceflight works. They wouldn't undock this. They wouldn't undock Piers with Progress if they weren't 100% sure that Nauka is going to get there. They would not do this. So like I said, people need to have some faith in our Russian bros across the pond. It took them a second, but they got it right. Is it bad that watching the Piers undock made me really sad? It kind of sucks, to be honest with you, but it's going to get replaced with a much bigger module and then a better docking system. So, it kind of sucks, but it's also really cool, man. It's the circle of life. Is Piers where the small leak was? No. Piers has been in operation for basically since 2000. And literally has never had a problem. Except that there's been some docking anomalies here and there, but that's mostly with the capsules coming up. Yep, there's Rasavet right there. So, look, it takes a second to figure this stuff out. It takes a second to get back into the swing of things. For Russia, it's been 2 decades, man. I bet you half the people that are working, more than half the people working on Nauka are not people that they probably weren't even born yet when the functional cargo block program became a thing. Probably weren't even born yet. What's the oldest module on the ISS right now? So, Corey, by manufacture or by launch?
Discovery, go at throttle up.
Hey, Spodrum, 6-month resub. Yeah, they have re-entry photos, Euler. So, a lot of the modules that are on the Russian operational segment, Piers, Poisk, Zarya, Zvezda, Rasavet, well, not so much Rasavet, but those modules were designed for the Mir 2 space station. To get a good date on when these modules were manufactured, they were supposed to be launched by Buran. That should tell you everything you need to know about how old some of these modules are. Zarya and Zvezda and Nauka, for what it's worth, were manufactured in the late 80s. You know what the messed up part is? So was most of the U.S. operational segment. The U.S. operational segment, the blueprints for that were drawn up in the 80s under the Space Station Freedom Program. He was in GoldenEye, right? Yeah. So in terms of manufacture, some of these modules are over 30 years old. Testament to the design. They're really good designs. I mean, you don't have to worry about like a space station rusting, for instance, in space. But operating in that environment, in the vacuum for that long is pretty... Well, that's pretty freaking cool. Testament to all these modules' designs. And in that regard, it kind of sucks to see Piers go, but it's going to get replaced with a much bigger version of the same module. It's not the same module. Piers is an airlock Soyuz docking adapter, and Nauka is a functional cargo block, which is big, much bigger. So, yeah, the Russians have an exact copy of Piers called Poisk, which is on the top. So, and then they're replacing Piers with a module called Prichel, which should be launched sometime later this year. Can we agree on the fact that what made space amazing is the fight for it? It's tough, Void. I always tell people that launching stuff into space is like playing a game of Tetris. You never win, you just get better at it over time. Seriously, it's like playing a game of Pac-Man or Tetris. You're never going to win. No. You're never going to win. You just get better. That's it. And hopefully we get some high scores by going to Mars and stuff. You know what I'm saying? You know what I'm saying? Got to get that 5-block. You're never going to win feels peepo, man. Yeah, no, space... You know, people know you can't win at Tetris, but people still play it. People know you can't win at Pac-Man, but people still play it. Hi, I'm a new reviewer. You are very knowledgeable. I'm curious, what's your educational background? Hey, Stumpy. I'm self-taught when it comes to this stuff. When it comes to engineering, I'm a 3D artist by trade, so I can make stuff in 3D for you if you want. Like I can make, like that's my background. But I've been teaching myself. I have about 10 years of learning this stuff under my belt, give or take. I read about space every single day, and I'm not just talking like, I follow space on a Twitter feed, dude. I go into some pretty good detail. Like I have NASA's system engineering book under my desk, and then fundamentals of aerodynamics here. I get hard into the engineering, and I like teaching people about what goes on and how the space program works. I've interviewed people that have walked on the moon. I've talked to people that have walked on another celestial body. I've interviewed them. I've talked to flight controllers. I've talked to astronauts. Been very fortunate, man. But it is a lot of work. It's hard to put yourself out here on Twitch and, literally have an open Q&A for the entire stream. I never know what someone's going to ask. If someone's going to ask a question about rocket science, I don't know. I don't know what people are going to ask. So you got to be pretty knowledgeable about this stuff. Yeah, no problem, Juan. You got this recently. Yeah. Mm-hmm. Yeah, that's right, Panta. Mm-hmm, mm-hmm. So, yeah, what's your favorite color? Red! No blue! No! Ah! I also like putting references into what I teach here. But I have NASA's good graces, dude. Their Twitch channel, NASA's Twitch channel, which is at NASA Actual, has shouted me out before, and I've worked with them on panels at TwitchCon before talking about spaceflight. I really like this stuff. Really like this stuff. A lot. Yeah. Yeah, it's fun. I enjoy it. When does that need returning? I bought it, Brimo. I bought it. African or European? I don't know that. So, I mean, Stumpy, if you have a question about whatever when it comes to space, I'll throw my hat into the ring, dude. I'm pretty damn knowledgeable about this stuff, but see, like I said, going into space, and this even pertains to learning about space. It's like a game of Tetris. You never win. You just get better at it. And in that regard to learning about space, you're never going to know everything about it. Every time I learn something new about space, I realize how little I know about space. I've attributed to in the past to we're on Twitch, so I'd assume a lot of you guys play video games, right? I mean, me too. I'm a freaking dude. I played competitive Counter-Strike for a long time. This was back in Cyber Athlete Amateur League. I played 1.6 and Source and stuff for the old school gamers. I actually know what Twitch means. Twitch's namesake is Twitch shooting, first person shooters. So I played a lot of games myself, but when you're really into a new video game, I noticed that this happens with Minecraft a lot. When you're into a new game and you want to learn everything about it and you power play the game for 6 to 8 months, and then you figure out everything with the game, and then you're like, meh, all right, I'm done with that. That's what space is like, but it never stops. I decided I wanted to learn a lot about space a decade ago, and a decade later here, I still know nothing. You know what I mean? I'm not anywhere, you wouldn't see me going and making my own rocket, But I do know a good deal. I know more than most. More than most meaning more than the average person. I probably shouldn't work for NASA, But yeah, that's kind of where I'm at. I love what I do, and I love teaching people about space, and I love showing people about space. It's really cool. It's really cool stuff. Yeah. Good stuff. Yeah, Ninja, thanks. I know enough to be dangerous, but know enough not to do anything. Yeah, something like that, Tessa. So does the Atlas V program hand over to Starliner after separation? How does that work? Atlas V is a launch vehicle, T-Man. Starliner is the payload. Starliner is just the payload. That's it. Every launch that has a satellite on board. So, okay, say if Atlas V launches, the next Atlas V launch after Starliner is going to be Landsat 9. Landsat 9 is a National Oceanographic and Atmospheric satellite. It's a climate change monitoring satellite. ULA will launch it. And don't get me wrong, the Landsat people aren't just sitting there twiddling their thumbs when the thing is launching. They're monitoring the satellite. And then after separation, they hand control over of the mission to the Landsat people. So, the Boeing team will be monitoring it, right? But ULA is basically in control of the mission, so to speak, until separation. They're providing a service. Thanks for showing stuff. You bring the mystery down a bit. Yeah, Gannett, I try. Yeah, I found that Gannett, that's the thing, man. I found that there is a ton of misinformation and misunderstanding of how the space program works. There's a lot of misunderstanding. People, because it's a complicated subject. It's complicated. So what I try to do is translate it in ways that make sense. Just translate it, like kind of, like I don't want to copy Tim Dodd like every day. I know him. He's a friend of mine. I don't want to copy what bringing space down to the everyday person. I try, like, it's not what Tim does. I try to just explain stuff in a much more simple way. And sometimes that works, sometimes that doesn't. It's almost like taking a complicated subject and trying to boil it down to get the essential point is a hard thing to do. And I do that in real time, guys. Like, you never know. I never know what kind of question I'm going to get, Keep it up. Thanks, Paul. I don't know. That's pretty sus, man. Speaking of Landsat 9, look at this. Yeah. So, I'm just trying to show people, like, how useful the space program actually is, and why it's necessary. There's a lot of folks nowadays, there's a general sentiment that it's not needed and stuff. And that's not true. That's not true at all. Also, yeah, here, really nice picture of Landsat 9. You ever considered going a full-time Fortnite streamer? I would rather put a sledgehammer through my computer screen than play Fortnite. Let me put it to you like that. Appreciate your words. I enjoyed the stream. No problem, Stumpy. It's fun stuff, man. I mean, it's rockets after all. It's a giant freaking explosion factory that shoots explosion out the back. That's the coolest thing ever. Hey, nice Ferd. Also, I like cars a lot. Cars are my favorite. Yeah, it's funny, Jackley, because Destin is a rocket scientist, but yeah. Yeah, look at that. See, RL-10. Very nice. No step. No step on... Well, it's not a snake. Don't step on that. It's a composite overwrap pressure vessel, and it has hydrazine inside. You don't want to step on that. Are you going to play Minecraft today? Yeah, we got some time. Sure. Hey, there's the Centaur. That's a single-engine Centaur 3 upper stage for Landsat 9. Cool. No step on COPV. Yeah, see these tanks back here? These tanks are used for, it's used for tank ullage, and the second thing is that Centaur has a reaction control system on it. The thrusters for it are right there. You can see them. They have the red caps on them. That's the RCS for Centaur. They're located relative to this picture at 12, 3, 6, and 9. So there's another one right there, and there's another one right there, and there's another one on the other side. These are monopropellant thrusters. They use hydrazine, but it's monoprop, so they shoot hydrazine through a catalyst. There's like a little filter right before the thruster, and when that hydrazine meets the filter, it reacts with it, and it heats up the hydrazine and pushes it out the nozzle, which is really cool. That's what these things are for. One of them is for hydrazine for the back, and the other one is for what's called tank ullage. Tank ullage is basically when you're up in space, right? and you're draining fuel out of this, you don't want the pressure to drop, or else the stage can implode. And also, Centaur needs to keep the pressures up because those tank walls on a Centaur are about as thick as a dime. It's called a balloon tank. They basically inflate the stage like a balloon, and that's how it stays up. Yeah, pretty nuts, right? So these have helium in them, or they could use nitrogen as well. I don't know what ULA uses. It's probably helium, knowing them. These fill the tanks with helium while they drain fuel out to keep the tanks at pressure. Yeah, it'll have hot gas thrusters. That's right. Void, what's going on? Are you okay? Okay? Screw your. Are you all right, bud? No. Yeah, it's most likely helium. They use helium because it's light, and yeah, what Kamir said. You sorry? I'm not asking for an apology. I'm asking if you're okay. You all right, man? I'm trying to figure out what's going on. Are you talking about something else, or? CS 1.6, yeah, you aimbot. Oh, man. No, I screwed up. I'm sorry. I'm not asking for an apology once again. All right, as long as you're good, man. All right, so that was the OFT-2 press conference. Like, you don't need to apologize. Just made a typo. It's all good, man. I get it. I just want to make sure I didn't piss anybody off. You know? No, I screwed up. I'm not even trying to apologize. Okay. Sure. I'll let it go. So, yeah. That was the OFT-2 presser. We could talk more about this during Space News. Starting around 4 and going till indeterminate time, because chat, if I say a determinate time, chat will give me crap. When's this launch happening? Starliner. It's launching on Friday. At least they're targeting Friday at 2:56 p.m. Eastern time. Coverage of the mission will start at 2 o'clock Eastern. But we got to be careful. Well, they got to be careful. There is a low probability to go. So the probability that it's going to launch right now is sitting at about 40%. The reason is because long story short, lightning. There's cumulus cloud rule, and what was the other two? Long story short, they're worried about the rocket getting hit by lightning on the pad and getting hit by lightning on the way up. I don't think I need to say why a rocket full of hydrogen, oxygen, and solid rocket fuel getting hit by lightning could potentially be bad. Yeah, they had a bad experience. NASA learned the hard way one time. Almost learned the hard way, I should say. One time with lightning hitting the rocket. You got to be careful to what's called your commit criteria. Yeah, thanks, Dr. J. I found this epic Rockwell brochure about the space shuttle. Oh, very nice. Oh, wow. Yeah, I'm gonna go ahead and download that. Give me 1 second. There's a lot of medium about Space News over the weekend. Yeah, there was a lot of... Yeah, I know. It's the $2 billion thing. Space News is going to run long again today, guys. I can see it coming because people are going to want to... People want to learn about what's going on with that. So, I don't know. I do want to play an early hours game. I want to get into the Minecraft server and see what's going on. I haven't been in there in a little while. I'm going to qualify it. I'm going to put that PDF in my shuttle folder, in my research folder. I had a bad experience, Element. Damn it, I'm deaf. I'm gonna download this for research purposes. Anyway. You're gonna shut up for like 3 days. Sorry, see you all later, love you. Void, okay. You don't need to, but alright, man. What are your thoughts on the big SSTO? Just tuned in. Pilch, thoughts regarding what? We still need to button up a couple more things. There's a lot of open design things that we need to close up, and that's what I want to do today in Kerbal, but it's yeah, there's building the launch pad, dude, is what I'm worried about right now. And it's not that I'm worried, I'll be honest, it's not that I'm worried that I can't do it. I'm worried because I haven't built it yet, you know? So just show this meme during Space News. Yeah. Just show this. Human people often compare likelihoods to the likelihood of getting struck by lightning. The thing is, you have a lot of... Yeah. It's a lot of mass to verticate. I mean, Havoc's, it's not. It really isn't, dude. The SSTO is like 180 tons. And I know people are going to be like, dude, that's 180 tons. I'm not really worried about that part. I'll be honest with you. Yeah. I'm not worried about that. Really. It's not an issue to me. I'm worried about part count with the pad. To be honest, that's the big one. I'm worried about part count. Why am I worried about part count? Well, I'm worried about part count with the pad because the SSTO is 500 parts. And the pad is most likely going to be about 500 to 600 parts as well. And now that's not a lot of parts, but if I put it at the launch site, that's 1,000 parts with the SSTO and the pad, and then 1,000 parts for the other SSTO and the other pad. So that's 2,000 parts in scene. And we got to remember that if I the whole point of the SSTO is to be able to integrate quickly, right? And being slowed down by part count, right, even though the integration options don't take as long, will, like, say because of the high part count, it takes me 30 minutes to launch the SSTO, all right? The Freedom rocket, which is a more complicated rocket, it takes more time, but it's less part count. They end up taking about the same time and totally defeat the point. So I'm not sure what we should do. I'm not sure. We'll talk about that. We'll talk about that during Kerbal. That's something that we have to figure out. Is it possible to make the big pad work for the big and little SSTO? I don't see how. I mean, I'm sure I could think of something, but my idea was, because of deadlines, was to just scale up the pad. I made the pad scalable. So instead of making one pad that does two things, I made one pad that could be scaled easily to another SSTO. Once again, I made that design decision because of time. Because building a pad that launches both of them would be a little bit on the complicated side to engineer. And once again, in the name of deadlines, I opted for a simpler solution, making the pad scalable just like I made the SSTO scalable. We do have some problems with center of mass and center of lift. The aero shell is actually lighter than the aero shell on the smaller SSTO because of... it's lighter because some of the parts in KSP aren't scaled with mass correctly. Like, we have a triangle that weighs like 40 kilograms, and the triangle that's 4 times the size weighs 90%, or has a mass of 90% of that. So, you know, we have the small triangle that's 40 kilograms, and then the triangle that's 4 times the size of that is 150 kilograms, and it should be 160. So that ended up throwing my mass off a little bit. We have to figure that one out. I'm not sure how we're going to figure it out, but we can. It's not decommission the small one. Well, for testing human, I might take that pad offline. I might recover the pad, maybe not the SSTO, but the pad for now. I don't think that would change the center of mass much. Yeah, I didn't think so either, Core, but here we are, you know. Would you be able to just gizmo the other pad 2.5 kilometers away? The small pad, I'm thinking about doing that, someone. I'm thinking about quite literally just moving it. Putting the entire pad on landing gear and just moving it like what we used to do with the boats. Remember when we tried to launch boats back in the day? Off of the launch pad? We would just roll it off and just roll it into the water. How's landing going to be impacted to scene load with Chungus and small 2 pad? Yeah, Havocs, that's... I prefer to land from runway 27 in that regard. The reason is because the pad and everything renders before you're on final approach. If you're coming in for landing on runway 9, the pad renders right when you're doing the flare, which I never liked. I can't stand that. So yeah, we got to figure out something. But see, with the small pad, we're still going to have to replace it over time. We still have to replace the pad over time. Stuff does break. So do I make a pad that's fixable right on the spot right there? Or do we make a pad that we can easily just roll back out into position? There's a lot of things to kind of consider, you know? You guys are talking about the desert. We could do that. I could make the desert the launch facility for the small one. But if we did do that, I'd have to buy the desert first. I have to send a plane out because it's behind fog of war. And mission mode rules say that I have to buy that property. And if we launched the small SSTO from there, it's 6 degrees inclined. Because it's 6 degrees south latitude. So I'm not sure the small SSTO would be able to overcome that kind of inclination change. So I wouldn't mind using 2 separate pads for small and large SSTOs. That would be okay. If anything, operating the big SSTO out of the desert would probably be preferable. But also at the same time, guys, the desert runway is hard to land on because it's shorter. So for the bigger SSTO, I might run out of runway. I like KSC's long landing pad. So that means we could operate the small SSTO out of the desert. But if we do that, that means it's much less likely to be able to get anywhere near the station, because even at when you launch at 6 degrees inclined in Kerbal or in real life, you're not taking full advantage of the velocity gain that's imparted on the vehicle launching close to the equator. So I'm not even sure if the SSTO can make it into orbit in a 6 degree inclined orbit. I'm not 100% on that. So that's probably my biggest outstanding thing right now with the pad and everything. I don't know how I'm going to... I'm not sure how I'm going to do that. Can we augment the small one for water landings and then float the pad? Why don't I just have the pad floating in the water and then build a ramp to it? I know that works. But then again, docking 2 vessels together floating in water can crack and strike stuff in a different way than it crack and strikes stuff on the ground. In real life, it's 400 Synerd. I'm not sure what it is in Kerbal, but I know it exists. Yeah, there's a lot of stuff to weigh there for sure. When you buy the desert, do you need to pay for an upgraded runway? No, the desert is just there. It doesn't have an upgradable runway. The runway is just there, Havoc. So we buy the whole facility. The drop at the end of the desert runway is a lot more forgiving to overrun than KSC's, though. Yeah, it's something to contemplate. But like I said, Pilch asked what my thoughts are with the SSTO program. I'm not scared of making the pad. I know we can get the pad to work. Guys, someone now that we're thinking about it, dude, is there anything really particularly stopping us from... Okay, stupid idea. Is there anything really stopping us from doing something like this with a transporter erector? Like, is there anything really stopping us from doing that? Now that I'm thinking about it. Like, I could make a milk stool adapter for this. I already have an adapter. I already made it. Holy crap, dude, I already made the adapter. Now, okay, hear me out. So some of the first tests for the SSTO before I had the pad up and running was launching it off of Freedom's launch pad, which needed an adapter plate to adapt, that to the SSTO, right? Hang on, scrolling through. There's the crane. Nice. So, I'm actually kind of wondering... Nice. There's nothing really stopping me from putting that milk stool on. I'd be worried about hierarchy stuff, but see, there it is. There's the adapter. I made the adapter right there. That adapter is designed to withstand the thrust from these engines, and it uses... I made the flame trench out of radiators to be able to flux the heat. It does work. I could use the payload integration crane for the big pad to be able to put the adapter on when the pad is in the vertical position. We put the adapter on, and we could just make one transporter erector that has 2 integration points. Didn't that adapter keep blowing up? Yeah, it kept blowing up, but the idea is the same, Casper. Yeah, we could milk stool it. Milk stooling it would solve the problems, but we have to be sure that the hierarchy gets transmitted correctly. Meaning that this still figures out that when I dock an SSTO to it, it's still the root part on the SSTO. It's a little bit of a hierarchy jiggling game, but yeah, I don't see why we couldn't do this. Why is it called a milk stool? Because it looks like a milk stool. It looks like the stool that people would sit on when they're milking a cow. It's a slang term for it. What is that on the right? What is what on the right? This? That's Skylab? That's Saturn V in its cargo configuration? How far above parts do the engines have to be to prevent cooking on them? It really depends on the emitter, Pilch, and how much thrust it's putting out. You need a filament light bulb to hold over your head when ideas. Yeah. See, even talking about brainstorming it for a second, I could make one pad that can launch both of them, I guess. It's possible. That'll be a little bit on the difficult side to prevent drifting. Drifting will occur with this. Yeah. It'll be something that we have to consider. But even if drifting does occur, I can just reset the pad because the pad isn't rolled out somewhere in the middle of in a field somewhere. It's bar stool since it's tall. I mean, Forlorn, I'm just saying what NASA called it. NASA called it a milk stool, but it does resemble like a bar stool, I guess. I'd go separate pads. Otherwise, a problem on the pad grounds the whole program, right? Yeah, I mean, it has the potential to do that. But operating 2 pads will be costly, Havocs. Like, Havocs, all I'm thinking is that if I spend an hour rolling a frigging pad all the way out into a field somewhere, and then we go to use it once or twice, and then we use it and it Kraken strikes for whatever reason, then yeah, we're gonna have an issue. But also, when the pad needs maintenance, that's downtime. It's gonna take me an hour to roll a new crane out there, for instance. Unless I could make the crane modular and just reattach a new crane to it. If we float the small pad, we can tow it to inclined orbits. Yeah, but Wookie, that takes time. That's the thing. That takes a while to do it. I mean, it's possible, but it takes a while. The pad would need to be redesigned, dude. That's the other thing. Pad would need to be totally redesigned if we were going to do something like that. The reason why is because the pad center of mass is not in the center of the pad. So when we went to fuel the SSTO, right, the pad would list into the water on one side because it's too heavy. Yeah, we'd have to use ballast tanks and counterbalance it like on a real ship. But once again, it's doable. It's like, that's all doable, but it's stuff we need to discuss. That's in Pilch, like I said. Hey, Bill was there. Oh, why wasn't he in the presser? Huh, cool. Bill was at the launch readiness review. That's cool. I just made a launch pad in my workshop. Nice. How's the big SSDO coming? Sounds like you're grappling with some of that. The big SSDO is approaching operational capability, Doom, or at least, well, I shouldn't say operational, a finalized prototype. It's approaching a finalized prototype.